Hello, I'm Randy Phelps. I'm a Synthophone player and would like to talk in more detail about the Synthophone's harmony features today. If you're brand new to the Synthophone, the whole idea of it, you might want to check first at www.softwindinstruments.com or do a Google search for Synthophone, Synthophone, like saxophone, but syntho in the front of it. And a lot of things will pop up, and there's a lot of basic information that's available on the web. But today I want to talk about the harmony features of the Synthophone in particular. And if you take a look to the left side of your screen, you can see that there are a lot of variable harmony tables that are set up on the Synthophone. And over on the right side, where the word tacit appears, this is I've got active Sibelius, the notation software, so that when I play something it can be recorded, and then you can see visually what the voicings of the harmony look like. So the first thing I'm going to do is just to activate that Sibelius so that it will receive some notes. And over here on the left side, I'm going to choose harmony table number 1. And you make those selections using the keys indicated on the Synthophone. I'll hit the high E flat key and the low D key, and then if I want to go forward a table, I use the E flat as an increment key and the low C key as a decrement to go back. Okay, so this is a example of some Synthophone notes. Those notes are all coming from lookup table number 1, which is mostly thirds and sixths. If I add another pitch, and then if I squeeze on my reed, which has a small magnet underneath the reed attached to a metallic tongue, this little magnet traveling up and down inside the Syntophone's mouthpiece sends data to the computer and makes the inversion changes happen. So you can switch from what you just saw to by squeezing on the reed. Okay, and then if I go to lookup table number 2, again using the fingering in the chart on the left, I get this. And then to lookup table number 3. You'll notice that I'm coming in and out of harmony. I'm adjusting that using a thumb membrane that's on the back side of the Synthophone, a thing called the Thumb Express. When I press my thumb on this little membrane, I engage the harmony, and when I release the pressure on the thumb, the harmony goes away and I'm back to a unison. Then finally on harmony table number 4, this is the first one of the user harmony setups, and I'll show you how this works. Over on the right side of the screen, in order to open up the table for your own harmony choices, you have to hit the indicated keys, the low B flat key and the low D, and you press down on the E flat and C keys at the same time, and that opens up the lookup table. And then you can play notes of your choice that become part of the harmony. Now sometimes it's a little tricky to get the B flat and the D key and the E flat and the C to engage. I hold down the B flat and D first, and then hit the two E flat and C keys at the same time. Most of the time it works fine, but sometimes you have to do it a couple of times to get this to engage properly. So I have done a preset where this is already set up, and when I do that, I'll get a specialized harmony effect which sounds like this. You can see that when I'm playing notes of diatonic to the key of C, I'm getting either a unison C or an octave C. The same thing is true for all of the notes of the diatonic C scale. But when I hit a chromatic tone, I get a sort of a dissonant voice leading harmony. And that only happens when I'm playing notes that are chromatic to the key. Now I achieved that by going through each note and using the fingerings over on the right side here with the code and entering a C, and I hit all C's so that I would get unison or octave, and then I did the same thing with a pitch of D, hit all D's, and I went through the entire diatonic C scale that way. The notes in between are being harmonized with the usual pre-programmed data that's in that particular harmony table. Over on the left side of the chart here, it says I'm in table 4. It says it's this user chords same as table 1 when initialized. That means the harmony was mostly in thirds and sixths. But I have interrupted the use of this harmony on all the diatonic notes of the C scale and put in my own choices, which in this case are all unisons or octaves. And I'm controlling the fact whether it's a unison or octave with the jaw pressure. If I squeeze hard, I get a unison. If I release the jaw pressure on my reed, I get octaves. Same thing for all of the notes of the diatonic C scale. But if I go to a chromatic pitch like an E flat, then the harmony from the existing structure in the lookup table, which is still there, comes in. The pressure on the reed still affects the number of notes in the voicings, however. So if I vary the lip pressure carefully, I can get from what you see here on the screen 4 notes down to 2, down to 3 sometimes. Okay, and then if I go with the same control, that is the jaw pressure controls and so on are the same, but I go to the next lookup table, I get a different harmonization because its default characteristics are different. So this is the next lookup table, table number 5. Okay, so that gives you some idea, I guess, of some of the personal choices that you could make. It opens up a huge amount of variability that can be used with this basic approach with these lookup tables. And then you can, of course, save these as a master patch once you've made your choices. So I'll go from this one that has this particular characteristic, that is me squeezing tighter reduces the note to one note and so forth, and go back to a previous setup that doesn't have that and also has a different harmony table associated with it. So I can change master patches by just doing a key combination on the sax. And then I'll go back to the one that I just was on. The master patch changes are very, very handy for live performance situations, pit orchestra kinds of situations where you have to change a lot of variables all at once. And there are 32 master patches possible on the Synthophone. So you can quickly change from one to the next. Here's yet another one. Then back to the one in between. And then back to the one with the octaves. Okay, and what is the final step here? I'm going to apply this particular control to something that has some moving parts in it. And in order to do that, I'm going to open up instance of Logic, which contains Unify. Unify is a software, I guess you call it like a shell or a holding program that allows you to assemble complicated combinations of software instruments and bring them back under a particular name. So what we've been listening to in the background here is partly my 5-part alto saxes along with a hardware synth made by Roland, and those two are in combination. But now in this particular Unify layer, I'm going to wake up another group of sounds which is now darkened out. When you click on it, this thick and thin variation, which has moving parts, comes into play. And I'm going to control the whole thing using this particular personal harmony that I've inputted. So that's the moving part. Well, it sounds like this. And one other control feature on the Synthophone, I have sustain pedal function on this membrane on my right thumb. So if I hold down the right thumb, I can keep the groove in this moving part going. So I'm just holding down the pressure on my right thumb. So I hope that gives you some idea of the possibilities of this harmonizing feature. Thank you very much, and I'll be back with another demo soon.